So, welcome back, students. Welcome back, Abafundi. We are starting a new module today, and that is data handling. And I think it's one that a lot of you will find reasonably straightforward. So we get to dive straight in. We get to quickly talk about the stuff that you should know so far, from up to and including grade 11. So let's have a look. So basically, we've got what we've called a little cheat sheet on what you should know so far. Right, so the first kind of concept that you should be comfortable with is what we call the mean. All right, the mean of some numbers is just found by adding them up and dividing by the number. All right, so there's no formula provided for that. There's also no formula provided for this. The mode is just the data item which occurs the most often. The range is the biggest minus the smallest. And then we've got this idea of what we call quartiles. All right, and this is a useful little formula. What we're going to do is we're going to add 1 to the number of data items and divide by 4. And that will tell us not the first quartile, but its position. All right, and if we want to find its position, then for the first quartile we do that. To find the position of the second quartile, we just double that number, and the third quartile we triple that number. Right, now if it turns out with any of these that they don't end up on a whole number, for example, you end up with, say, the 15 and a half term, all right, then we just average the ones on either side, all right, or even if it worked out to the 19 and a quarter, let's say the third quartile was in the 19 and 1/4 position, we just average the 19th and the 20th, okay, all right. We've then got a concept called interquartile range, and that's just the third quartile minus the first quartile. Then there's this idea of what we call a 5-number summary, and the 5-number summary is just those 5 numbers. It's the smallest number, it's the first quartile, it's the second quartile, which is also called the median, the third quartile, and the maximum. And those numbers can be used to create what's called a box and whisker plot. All right, and a box and whisker plot starts, the left-hand whisker starts with the minimum, the right-hand whisker ends with the maximum, and then we've got a box in the middle here, and the box starts at Q1, the first quartile. The median is a line in the middle of the box at Q2, the second quartile, and Q3 is the right-hand edge of the box. Okay. One of the things we need to be able to do, if you can just turn the page to page 45, we need to be able to comment on the symmetry or otherwise of data. All right. And so often people get this wrong. They say, oh, there's more data below the median. That doesn't make any sense. The median is the middle of the data. All right. So here's the median, and here's the median. There's just as much data above, bigger than the median, as there is below the median. But what is true for negatively skewed or data that's skewed left is that the data below the median is more spread out than the data above. Positively skewed or skewed to the right, the data above the median is more spread out than the data below the median. Okay, and where what we describe as symmetrical data is when this kind of the spread is sort of the same on either side. Right. We sometimes put a little cross on here to show the position of the mean. All right. And with negatively skewed data, the mean is typically less than the median. With positively skewed data, the mean is typically bigger than the median, and with symmetrical data, the mean and the median would likely be very close together. Right, we've also got the corresponding histograms, okay, and so a positive skew actually kind of slopes downhill as a histogram, a negative skew slopes uphill. If you just stop and think about the spread of data, it makes sense that they would be like that. Okay. Right, the next concept is the thing called standard deviation. And what standard deviation is, it's a measure of how spread out the data is. The bigger the standard deviation, the more spread out the data. The smaller the standard deviation, the less spread out the data. Right, and we need to know how to use this formula which does get provided. Okay, and this formula says that we take every x value, we subtract the mean, all right, we square that result and we add it up for all of them. And then we divide by how many we are. In other words, we work out the average, all right? And that gives us not the standard deviation, but it gives us what we call the variance, right? And the variance is the square of standard deviation. So in fact, to get from here to the final answer, we would square root. Okay, right. Interestingly, in maths, there are two sigmas in mathematics. There's that one, and there's this one. All right, and this is a lowercase s, and this is an uppercase s. All right, this one, and what's very cool is they both occur in this same formula. This one represents standard deviation. And this one, we remember from our sequences and series, stands for sum, to add things up. Okay, and they both occur in this formula. Right, so we need to know how to calculate a standard deviation without using a calculator. We also need to know how to do it on a calculator, and we'll have a look at that. Right, generally speaking, one standard deviation either side of the mean will include 67% of the population. Okay, so that's just a rule of thumb. Two standard deviations either side of the mean will include 95%, and three standard deviations either side of the mean typically will include all the data items. And we're talking there about what we call normally distributed data. Okay, all right, so let's now look at what we call grouped data. All right, so with grouped data, we don't actually have the original data. We have the data has been grouped. So for example, these are maybe marks on a test. Between 0 and 10, 5 people got that mark. Were in that range. Between 10 and 27 people. Okay. Now, when we want to estimate, and it is just an estimate, an estimate for the mean data, what we do is we assume that these 5 people averaged out at the midpoint. So in other words, for those people, we use a mark of 5. For these 7 people, we use the midpoint of that interval. For these 8 people, we use the midpoint of that interval. Right. And so then what we do is we take each mark, each midpoint, and multiply by the frequency, add them all up and divide by how many people there were all together. All right, and this formula here says exactly that. So the mean is found by taking the frequency times the midpoint. All right, x represents the midpoint, adding them up and dividing by how many there are. All right, and that formula does get provided. So here's a little example of just with that data there. 5 people got a mark of 5. All right. A mark of 5 was achieved by 5. A mark of 15 was achieved by 7. A mark of 25 was achieved by 8. So notice what we're doing. We're taking these frequencies, all right, and we're actually multiplying by the mark. So I've actually got x times f rather than f times x. That's the same thing. And then obviously there are a total of 20 people here. If we add up 5 and 7 and 8, that's 20, all right, and that would give us an estimate for the average mark. It's not the exact mark, it's not the average mark, because we don't have the original data. So it's just an estimate, but it works out surprisingly accurately. Okay, the last thing is what we call a cumulative frequency plot. Okay, and basically that now is when we plot one of these, the cumulative frequency, we add, each time we add the next frequency in. So what happens is that this mark over here of 12, for example, okay, and sorry, this frequency of 12 means those are the people that got a mark of less than 20. These are the people that got a mark of less than 30. So it continues to build. The last cumulative frequency, the last number at the bottom here, is the total number. Right. And when we plot a cumulative frequency, and this is a really important idea, we plot the right-hand point of the interval with the cumulative frequency. So I'm just going to try and show you here. We would plot 10 and 5. 5 being that number there. The next point would be 20 and 12. And the next one would be 30 and 20. So we don't use the midpoint when we're plotting the cumulative frequency curve. All right, also called an ogive curve. We use the end point. We use the midpoint when we are calculating an estimate of the mean. Okay, the basic shape of a cumulative frequency plot is like that. It tends to kind of go up, get a bit more steep, and then flatten out. Okay, this top number, the last height, the maximum height it reaches, will be n. All right, okay. I'm going to just try and improve on that because I didn't do that very clearly at all. Let's see if we can do that a bit better. All right, so from here across to there, there would be n. Okay, now off a cumulative frequency curve, we can read the median. The median would be halfway up. This isn't where we read the median. We read halfway up or we read across. This would be the median value over here. The third quartile would be 3/4 of the way up, and the first quartile would be 1/4 of the way up. So for example, if we were given one of these cumulative frequency curves, we could calculate the interquartile range. All right, it would be an estimate because we're reading off a graph, right? But reasonably accurate. Okay, now that is what you need to have known up till now. So what we're going to ask you to do now is we're going to ask you to pause the video and we're going to ask you to try these questions, which is just revision of grade 8, 9, 10, and 11 data handling. All right, we'll go over them shortly. Okay, so this first one, we want to get the mean of these numbers. So remember that in a stem and leaf diagram, the first number here that's the tens digit, and then so we've got 13, 13, 14, 16, 17, 17, 18, 19, 19. So we can put all those into our calculator and let's look at how that's going to look. Okay, so we're going to go mode 3. Sorry, 3. Mode 2. Sorry, one variable statistics. Okay, and then we're going to put in all these numbers. So we're going to go 13, 13, 14, 16, 17, 17, 18, 19, 19, 19, 20, 20, 22, 22, 23, 24, 27, 29, and 34. Now it's obviously really important that we've got this right. Okay, so before we do anything else, let's just check our entry here. I'm going to make the calculator a little bit bigger. Okay, let's just have a look. So we have got 13, 13, 14, 16, 17, 7. Okay, so I have made a mistake here. I've only put one 17 in. So I need to put another 17 in. We've got 18. We've got, this should be 19. I'm going to change that to 19. 19, 19. I'm going to change that to 17. Okay, I hope I've now got it right. 20, 20, 22, 22, 23, 24, 27, 29, and 34. Okay, there are 19 numbers here. All right, so then we can press all clear and then we go shift stat. We want the variables about this data, so we're going to go for 4, and we can get the mean by going with option 2. So the mean of these numbers is 20,32. We can get the standard deviation of these numbers by doing the same thing, but now we're going to go shift stat and we're going to go 4 and we're going to go for item 3. Right, and we're going to press equals. $5.29. Okay, 5,29. Right, the range is very straightforward. It's just the biggest minus the smallest. So it's going to be 34 minus 13. 34 minus 13, 21. The mode is the most common one. Which one occurs the most often? And that is 19. There are 3 19s. The interquartile range. Now, the way we're going to work out the interquartile range, remember, we're going to take that formula n plus 1 over 4. So here we've got 19 plus 1 divided by 4. It actually comes to 5. That means that our first quartile will be in position 5. 1, 2, 3, 4, 5. Our second quartile will be in position 10. 6, 7, 8, 9, 10. Our third quartile will be in position 15. 3 lots of 5. 11, 12, 13, 14, 15. All right. And so our interquartile range is going to be 23 minus 17. 23 minus 17. And 23 minus 17 is 6. Okay. The 5-number summary, remember the 5-number summary is our smallest numbers, which is 13. Our first quartile, which is 17. Our median, which is 19. Our third quartile, which is 23. And our maximum, which is 34. There's our 5-number summary. Quite often it gets written in a set. It doesn't have to be written in a set. Okay, and then lastly, we're going to draw a box and whisker. So the smallest number is 13. There's 10, 11, 12, 13. So that's going to be our left-hand whisker. Over there. Our biggest number is 34. 1, 2, 3, 4. Okay. I don't want an arrow on the end of that. All right. And then our box starts at 17. So there's 16, 17. So let's do that. And our box ends at 23. So that's going to be over there. All right, and our median is at 19, which is going to be over there. Something like that. Okay, and our whiskers are going to go to there. Okay, all right. I don't think the question asked it, but let's just comment on the symmetry of that. Is this data positively or negatively skewed? It's actually positively skewed, and we can also write skewed right. Oh, sorry, the question did actually say describe the symmetry. It's positively skewed. We can also say it's skewed right. You don't have to say both, but you do need to be comfortable with both of those terms. Because, for example, you could be asked to draw something that is skewed right, draw a box and whisker that's skewed right, and you need to know. All right, and remember the reason it's positively skewed or skewed right is because the data above is more spread out than the data below the median. Okay, right. So we're going to stop there. We're going to ask you to try questions 2, 3, and 4, and 5, and even 6 before the next lesson. We'll go over them next time, and then we're going to start soon thereafter. We're going to start another revision worksheet, and then we are going to get into the grade 12 work.